A force 150 Newton acts on an object which moves 6 meters in the same direction as the force. Full stop. Calculate the work done. What you are going to do is, now anytime you are solving physics question, make sure you look for the parameters given. Now look at the first parameter. This is the force. So you write it out. Force is equal to 150 Newton. And this is the displacement. It says act on an object which moves 6 meters. That's displacement in the same direction as the force. So now that we know the two parameters given, what did they say we should find? They said we should find the work done. So when you are solving physics question, first know the parameters given, then look for what they are asking you to solve. Check what they are asking you to solve, then you go ahead. Work done is equal to force times distance. Now, why we are going to use, okay, I can use cos theta. Now, remember, they said, what will be our theta here? They said it's moving in the same direction. Remember that if it's moving in the same direction, that is parallel. And if the two displacements, if force and displacement vector, if they are parallel to each other, the angle will be 0 degrees. So if I do this, it's going to be force is 150, then displacement is 6, and cos theta is going to be cos 0 degrees. So W is equal to 150 times 6. 6 times 0 is 0. 6 times 5 is 30. Write 0. Keep 3. Then 6 times 1 is 6 plus 3. That will be 900. Now, this one is, cos 0 is going to give us 1. So our final answer will be 900 joules. So that's our answer for this particular question. The work done by this object, the work done by this force on this object is 900 joules. An object is lifted vertically through a height. This is height. Through a height of 4 meters by a force. Now, the height here is 4 meters. So, if you look at that height is just the displacement. Yeah. By a force equal to its weight of 250 Newton. So, force. You know, I was explaining this the other time. That you may not be giving force. Like, look at the way they twisted this question. They said, by a force equal to its weight. So, meaning that the force here, the force you apply to lift a block of 250 Newton is 250 Newton. So, you must have applied the same weight of the block. That's the force that equals to the weight of the block to be able to lift the block. So, the weight of the block here is equal to its force, the force applied to lift it. So, that's 250 Newton. The question asks us to find the work done against gravity. Yeah, now look at that. Gravity always push things down. Gravity always, if I throw anything up, gravity always decreases the speed of that object. Do you understand? So gravity is usually a negative work on any object that is going up, not on any object. Any object that is going up, gravity will do a negative work on it. Any object that is coming down, gravity will do a positive work on it, because gravity always works downward. Gravity always acts downward. So if I lift a block upwards, gravity is doing a negative work on it. So this question asks us to find, they said, calculate the work done against gravity. So gravity is coming down, gravity acts downward, but I'm lifting up a load against that gravity. So what is the work done against gravity? That's what we want to solve. Now, it's the same thing. Now, look at, now I want us to know what is the angle of inclination here. Now, look at, this is the object. In this case, this is the block. Now, I'm lifting the block up. That is my displacement vector. But gravity is pulling it down. Gravity is pulling it down. Do you get that? Gravity, this is the action force. Gravity is, I'm doing this work against this gravity. So the angle between, remember I said that if the displacement vector and the action force is opposite each other, is going to be 180. Remember what they asked us to solve. They said the work done against gravity. So your gravity will be towards is coming down. That's your gravity is acting downward while I'm lifting up this load against it. So that is opposite. And the angle for opposite is 180 degrees. So work done here will be force times displacement cos theta. Work done here will be force is 250 times displacement is 4 times cos 180 degrees. So work done is equal to 250 times 4 is going to give us 1000. If you if you calculate cos 180 degrees in your calculator, you are going to get -1. Yeah. So this is going to give us 1000 times -1 is going to be -1000 joules, or it can be Newton meters. Now, what this means is that this the force, the gravity, what this means is that gravity is doing this negative sign means gravity is doing a negative work on the object being lifted. Gravity is doing a negative work on the object being lifted. So that is that. Gravity is doing a negative work on the object being lifted. Now, this is what is telling us that. This minus sign is telling us that. So if you are asked what is the work done, it's 1000 joules. But what is the nature of the applied force? The nature of the applied force, that's the nature of the gravity on the load, is that it's doing negative work on the load. So that is the answer here. A machine performs 4800 joules of work in 20 seconds. Its power output is, so now a machine performs 4800 joules of work. That's our work done is 4800 joules. In the time here is 20 seconds. Its power, so we are asked to calculate power. You know that power is equal to work over time. Power is equal to work over time. So power is simply 4800, because that's our work here, over times is 20 seconds. So 0, we cancel 0. 2, we cancel 4 here, that's 2. We cancel 8 here, that's 4. 0. So therefore, our power here is going to be 240 joules per second. 240 joules per second. Or it can be 240 watts. 240 watts. So that is how to solve this. A body of mass 8 kilograms is raised through a height of, so height here is 5 meters, taking g as 9.8 meters per second squared. This is acceleration due to gravity. The gain in gravitational potential energy is, so here we want to find potential energy. Look at that. Gravitational potential energy. You know, the other time I was mentioning that we have different type of potential energy. We have electrical potential energy. We have gravitational potential energy. We also have mechanical. Was it mechanical I mentioned the other time? So we have 3 types of potential energy. And the formula I gave you was for the gravitational potential energy. So this is the formula. Formula is mgh. Look at the question. They said the gain in gravitational potential energy, that we should find it. So PE, there's the mass. Where is mass? Mass is 8 kilograms. So let me write that. Mass is 8 kilograms. So potential energy is equal to mgh. Potential energy is mass is 8, then acceleration due to gravity is 9.8, and height is 5 meters. Now if you do that calculation, you are going to get 8 times 5 will give you 40, and you multiply that by 9.8. So let us do that. 40, 9.8. 8 times 0 is 0. 8 times 4 is 32. 9 times 0 is 0. 9 times 4 is 36. If you add these together, you are going to get this. So our final answer is 392.0. So potential energy is equal to 392.0. Now 392, the unit of Mass is kilogram. The unit of this is meters per second square. Multiply that by, this is meters. So your potential energy is going to be 392 kilogram. This one will multiply this meter square per second square. So this is our answer for potential energy. Potential energy can also be in joules. Yeah, potential energy can be in joules. But if you want to write it in SI units, you can do it like this. A garage hoist lifts a load through a vertical distance of 3 meters. So displacement here is 3 meters. That's is lifting it up. If the force exerted is 2000 Newton and the lifting takes 12 seconds, the power developed is, so we want to find power. Remember that power is equal to work done over time taken. So in this place, our work done is, we were given force and distance. Remember that work done is force times distance. And the time is, force times distance will now be force times displacement over time. That will be our modified formula for power for this particular question. So power will be force is 2000 times displacement is 3 over time is seconds. So you divide 3 here 1, 3 here 4, 4 here 1, 4 in 20 is 5, then 0, 0. Power therefore is equal to 5 watt. Power is equal to 5 watt. So that's the answer to this question. So now we have solved 5 questions, and I've shown you, I didn't solve question on kinetic energy, but now for kinetic energy is 1/2 mv square. So if you are given a question and you are provided with mass, you are provided with velocity, just put it together and solve it. So I'm going to give you 2 questions for you to attempt and see if you can apply some of the things that I've taught you here. And the way I solved some of the questions with you, you can also apply it and solve the questions by yourself. Okay, so here is the task for you to attempt. We have 2 questions. First question says, a force of 350 Newton acts on an object and moves it 9 meters in the direction of the force. The motion takes 15 seconds. Calculate A, work done, B, the power developed. Number 2, a body of mass 12 kg is lifted vertically through a height 6 meters in 8 seconds. Take G is equal to 9.8 meters per second. Full stop. Calculate A, the force required to lift the body. B, the work done against gravity. C, the power output of the lifting machine. So you can pause this video, take down this question and solve them. So don't forget to like this video and subscribe and share it with some of your friends that you know will benefit from this. Thank you.